In this lesson, we are solving inequalities. So we're asked to graph this inequality, but we have to write it first because this is a verbal model and we need an algebraic model. So graph the inequality. 1.8 is less than the product of negative 0.3 and a number. All right, I'm just going to go in order. 1.8 is less than, so far so good, the product, so that means I'm multiplying. Okay, let's see what I'm multiplying. I'm multiplying negative 0.3 and a number. So negative 0.3 times a number. I could use n. Well, let's use x. Right? So there's my inequality. So now I have to solve it. And just like solving equations, the key is look at the operation being done to the x and do the opposite, right? So if I look at what's being done to the x, it's being multiplied by negative 0.3. The opposite of multiply is divide by negative 0.3. So I'm going to do that on both sides. Any number divided by itself is 1, so I just get x. On the left, 1.8 divided by 0.3 is the same as 18 divided by 3, which I know is 6. And a positive divided by a negative, that's our sad guy there, equals a negative. So it's going to be negative 6. And here's the one difference with inequalities, okay? Anytime you multiply or divide on both sides by a negative, flip the inequality. All right, now a lot of students, when it comes to graphing, prefer to have the variable first. If you look at this inequality, it sort of looks like it's pointing at the x. So if I were to rewrite it starting with the variable, it should still be pointing at the x, right? Now, when it comes to graphing this, I'm going to draw a line. Let's see. Yeah, I'll just do it down here. And I'm going to put negative 6 on my line, and it doesn't really matter. The other numbers are here and here. And I am not including negative 6. It doesn't say that it's less than or equal to, right? It just says less than. So I'm going to put an open circle around the number. And then since I want the numbers that are less than 6, that means I'm going to shade all the smaller numbers, right? These are all the numbers that are less than 6. So I'm just going to make like a thicker line here, and then I'm going to put an arrow on the end to show that all these numbers in this direction forever and ever are going to be less than negative 6. All right, so two things that we have to remember when it comes to working with inequalities. The first thing is that you only flip the inequality when you multiply or divide by a negative on both sides. The second thing is that when it's including the number, we need a filled in circle for our graph. When it is not including the number, we don't include it, so we don't shade it. It's open. All right, let's try the next one. This one is just graphing. Okay, so I'm gonna, just kidding, I have to solve it first. So, like we did with the last one, I'm going to look for the operation that's used. 2.7 is being added to p, so I have to subtract it to solve. Right? All right, so now I have p here. On the other side, I have negative 3.9 minus 2.7. Remember, that is the same thing as adding a negative 2.7, right? I'm just going to take a minute and talk about this. So negative 3.9 minus 2.7 is the same thing as negative 3.9 plus a negative 2.7. Remember, they're the same thing. So when I have players on the negative team and I have more players that want to join the negative team, I'm just creating a larger negative team, right? So I am going to add these numbers and it's going to stay negative. So I get 16 and then 5, that's a 6, and it's going to be negative. I did not multiply or divide by a negative, so I do not flip the inequality. And now I graph it. Here is negative 6.6, other numbers to the right and left. The inequality is less than, so I am not, there's no equal to on the bottom, so I'm not including the number. And I want the numbers that are less than, so I shade to the left. Again, this one's also to the left. And I put an arrow to show that all the numbers in that direction would satisfy this. They would all be less than negative 6.6. All right. Let's keep rolling. All right, so I look at what's being done to the variable. Every time, look at the operation that's being done to the variable. I look at my variable and I see that I am subtracting 5/9. I have to undo that by doing the opposite, so I add 5/9. And I'm going to do that here as well. Right? So a number and its opposite will always add to 0, like negative 3 and positive 3, negative 10, positive 10, negative 5/9, positive 5/9. That's always going to be 0. On the right, in order to add these fractions, you guessed it, I need a common denominator. All right, so my common denominator is 45. This would be times 9, so that's 27, but I'm going to put a negative because I don't want to forget that that negative is there, right? This is a negative 3/5, so I'm going to make sure I put that negative with the top number with the 27. Otherwise, I might forget that it's there. All right, so this is 25. So now I've just got to add negative 27 and a positive 25. So they're on opposing teams, right? 27 players on the negative team, 25 players on the positive team. The negative team will win by 2. And then I didn't multiply or divide by a negative, so the inequality stays. So that would be my solution. All right. Got a few more. All right. So again, I'm going to start all of these the same way. Look at the operation that's being done to the variable and do the opposite, right? So the r is being divided by negative 2.5. So the opposite operation would be multiply by negative 2.5. I'm going to do that on both sides. This is going to equal 1, because any number divided by itself equals 1. And I get just an r. I'm going to do the multiplication over here off to the side. Try to do it. Actually, I'll do it over here. I have more room. 6.25 times 2.5. That's 25. That's 12. That's 31. That's 10. That's 5. And that's 12. Hopefully I did that right. I did it kind of quick, but... And then when we decide on where to put the decimal, this has 2 places, this has 1 decimal place, so our answer needs 3. So I go 1, 2, 3. So on this side, oh, and I have a positive times a negative. Positive times a negative equals a negative. So I get negative 15.625. Now the last thing we want to do is look at our inequality and see, should we flip it? If we multiply or divide on both sides by a negative, then we have to flip it. And we did, right? We multiplied on both sides by a negative. So this flips. And that is our solution. All right, moving right along. Again, what operation is being done to the variable? Let's do the opposite. So I can see that the m is being multiplied by 1/3, which means I'm going to have to divide by 1/3. But we have a process for dividing fractions. We don't actually divide by 1/3. When we divide by a fraction, the way that we do it is we multiply by the reciprocal, right? So in order to divide by 1/3 on both sides, I'm going to have to multiply by 3. So I will multiply by 3. And if this were negative, I'd be multiplying by -3. All right, because on some versions it's negative. All right, so I multiply by 3. This just equals 1. On the right, I'm going to do top times top and bottom times bottom. I get 15 over 11. I did not multiply by a negative, so I keep the inequality the same. And now to graph it, I'm going to put 15/11ths right there. I've got numbers to the right, numbers to the left. It is greater than or equal to, so I need to include the number, which means shade that dot in because it's equal. It could be equal to 15/11ths. And the numbers that are greater than or equal to are on the right. So this time I'm going to shade this way. All right, 2 more. Write the statement blah, 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 blah as an inequality. Okay, not bad. So I see the word sum. So I should be looking for 2 things after that to know what it is that I'm adding together, right? So the sum of what? The sum of a number and 15.1. Okay, so a number added to 15.1. So far, so good. Is at least, okay, now think about what at least means. Because a lot of times when students see at least, they think it means less. But if you think about this, you have to be at least 16 to drive a car or to get an operator's license. Think about what that means. That doesn't mean less than 16 or you'd have your license right now, right? If it's at least 16, that means you have to be greater, right, older, or equal to 16. So at least actually means greater or equal to. So greater or equal to. And then we have -3.5. We'll just go on the other side. And we're not asked to solve this one, we're just asked to write the inequality. Now this could also be written as 15.1 plus n is greater than or equal to -3.5 because commutative property, right? Addition is commutative, which means 2 plus 4 is the same as 4 plus 2, right? So I could write the addition in any order. These would both be correct. All right, now we're going to write and solve this inequality, and we have -1/4, and then we have is greater than or equal to, so they actually gave it to us this time. So let's start with that. -1/4 is greater than or equal to, and then we have the product. So product means multiply, right? So let's see what 2 things I'm multiplying. I am multiplying -3/5 and a number. So -3/5 and a number. And let's go with n this time. I haven't used n too much. All right. So that could also be an x or a b or an m or whatever variable you choose, right? But now we have to solve it. Okay, so let's solve it. I look at the variable and I see what operation is being done. The n is being multiplied by negative 3/5, which means I have to divide by negative 3/5. But when we divide fractions, we keep, change, flip, right? We multiply by the reciprocal. So that's what I have to do on both sides. So I'm gonna, let's see if I can kind of squeeze this in. Let me draw this a little bit smaller. My greater than or equal to. And I'm gonna fit some parentheses in here because when you see me use parentheses, it's multiplication most of the time. So I'm gonna multiply by 5 over negative 3. And I'm gonna do the same thing over here. Multiply by 5 over negative 3. On the right, that equals 1. Any number, like any fraction times its reciprocal, is always going to give you the same number over itself, so that's why it's always going to be 1. Then on the left, I have a negative times a negative, and that's a positive. So I know this edge is going to be positive, and I have to multiply top times top, bottom times bottom, so that gives me 5 over 12. And then, do I flip it? Well, yes, I do, because I multiplied on both sides by a negative, right? I multiplied on both sides by a negative, so I flip the inequality. Now, if I wanted to write this with the n starting first, it would look like that. You don't have to. These are equivalent, but when it comes to graphing, which we don't have to do on this problem, most students find it easier to graph when the variable comes first. That's it. Let me know if you have questions. Send me pictures. I can help.